And I'll get those take-home quizzes ready for you. Hopefully back tomorrow. And tomorrow we'll get some new seats for you. Tomorrow.
I kind of don't have a calculator that works.
You and Jeff will have to. Or you can grab one from up there. Then we'll be.
I don't know if there's some of this stuff that's
All right, now here's what we're going over here today. You want to be able to explain the meaning of zero and negative exponents. We just went over that. Well, I just said 4 to the 0 equals 1, and I said 4 to the negative second equals 1/16. So hopefully you'll be able to tell me what those equal here by the end of the period. Also, you're going to have some expressions with zero and negative exponents. Okay, how to handle those, and then we're just going to go over some general exponent rules. Okay, these kind of rules you use over in our additional classes as well, like when you take geometry next year, and then eventually when you're a junior algebra 2. This is not on your guided notes. Well, in a second it won't be. This is the first sentence though, and I felt pretty confident when you answered that first one. You said you have seen positive exponents. You know that 3 squared means 3 times 3. All right, whatever that power is you multiply the base, is what we call it. 3 is the base, 2 is the power. That tells you how many times to multiply it. Okay, but what does it mean for an exponent to be negative or 0? Well, we did 4 to the 0 and we did 4 to the negative second. But what does 2 to the 0 and 2 to the negative third mean? Anybody know what 2 to the 0 is? Okay. All right, we'll go over that. And then we'll go over what 2 to the negative third is. So this is not on your guided notes, so just pay attention to kind of build this up. Math is full of patterns. When you figure out the pattern, you can generally figure out the rule. You're allowed to use your well, you don't really necessarily need your calculator. It's kind of a checker, that's fine. 2 cubed. Zach, what does that mean? 2 to the third power. You're not sure?
2 to the third power, it would be 2 times 2 times 2.
Do you know what that is?
8.
8. 2 times 2 is 4. 4 times 2 is 8. So 2 cubed is 8. 2 squared. Okay, Zach, what's that?
4.
4. 2 to the first power. What is that? That's just what? That's just 2. All right, now, what are the patterns happening here? The power is going down, right? 3, 2, 1, correct? 3, 2, 1. What's going on the right-hand side? That went from 8 to 4 to 2. Continue the pattern. What should be the next exponent? If I go 2 cubed, 2 squared, 2 to the first, what should be the next exponent? 2 to the 0, because we're going down by 1, right? 2 to the 0. Well, what's happening on the right-hand side? It's going, well, not going down by 2. Yeah, watch how you word that. 8 to 4 to 2. What's happening there, Maddie?
It's cutting itself in half.
Cutting in half. 8 gets cut to 4, 4 gets cut to 2, and what happens when we cut 2 in half, Maddie? You get 1. 2 to the 0 is 1. On your calculator, do 2 to the 0 power. Do 2 to the 0 power. I'm going to pull up my calculator here. Does it say 1? Do you believe I'm right now? Okay, so if I hit 2, and I got to do it this way to the 0 power, it says 1. All right, so we got to keep that pattern going. Now, here's the thing. When you use your calculator, it's going to start giving you decimals. I don't want decimals. I don't want decimals. Follow the pattern. What would be the next number? What would be the next power if you follow this pattern? 3, 2, 1, 0. What should be the next number? Negative 1. Goes down by 1. 2 to the negative 1. Follow the pattern. 8, 4, 2, 1. Cuts in half. What do you get when you cut 1 in half? 1/2. Okay, 1/2. All right, keep it going. 2 to the negative second. What happens when you cut a half in half? You get a fourth. You get a fourth. And what happens when you cut a fourth in half? All right, so we got that. This is pretty good here. So what is 2 to the 0 power? I said up above. That is 1. What's 2 to the negative third power? 1/8. Now, here's kind of the cheat on this, and this is going to be the rule. Look, do you see something very similar between 2 cubed and 2 to the negative third? 2 cubed is what? 8. What's 2 to the negative third? 1/8. 2 squared is 4. 2 to the negative second's what? 1/4. So, all right, if I told you 2 to the fifth was 32, what do you think 2 to the negative fifth is if you follow that pattern? 1 over 32. All right, so all you do is you figure out what 2 to the fifth is, put it over 1. This is the rule. So that if you have a negative exponent, it is the same as 1 over 2 to the positive exponent. It's going to be the same. 2 to the negative second is the same as 1 over 2 squared. 2 to the negative first is the same as 1 over 2 to the first. That's always going to be our rule. This just kind of shows it again. Now that's on your paper, right? So same idea. 5 to the fifth power, 5 to the fourth, 5 cubed, 5 squared, 5 to the first. 5, 4, 3, 2, 1, 0, negative 1, negative 2. This is always being divided by 5. What's 5 divided by 5? That's going to be what? 1. And then if I divide this by 5, it is going to be 1/5. What do you think that last one's going to be? There? 1 over 25. So 1 over 25. So here's our rule. 5 to the negative second is the same as 1 over 5 squared. That's going to give us our answer. Now, we got the rules printed out right there below. For any non-zero number A, anything to the 0 power equals 1, except for the case of 0 to the 0. We're not even going to worry about that. That's like crazy math. Don't even worry about that. So 4 to the 0 power equals 1. And A to the 0 power equals 1. Anything to the 0 power, 10 to the 0 equals what? 12 to the 0 equals 1. X to the 0 equals 1. Doesn't matter. Anything to the 0 power is 1. Negative exponents. What you do is you got 4 to the negative second, you make it 1 over 4 squared. If I got 2 to the negative third power, I make it 1 over 2 cubed. If I got 5 to the negative third power, I make it 1 over 5 cubed. And if I, instead of a number, I have a variable, I just make it 1 over that power. So what that means is x to the negative second is 1 over x squared. Y to the negative third is 1 over y cubed. Okay, so kind of from here on out, we don't ever want to write a final answer with a negative exponent. Okay, we want to make it a positive exponent because now we can. So if I got like x to the negative second, I'll make that 1 over x squared. Okay, so I'll do that. All right, so that's 0 and negative exponents. So we want to take a look at just a bunch of quick cases here. All right, 4 to the negative third. Now, simplify, which means we want to write it as a number. And then we want to no decimals. Mason? What do you got? Did I give you guys a notes, Mason? Were you here when I handed them out?
Yeah.
Okay. What do you think?
1 over 54.
1 over what?
54.
Not 54. You're close. Now, here's where you can use your calculator, like to do the math part. Addie?
64.
It's 1 over 64. The first thing I would tell you to do is write it as 1 over 4 cubed. Do that. Then you can use your calculator if you need to and do 4 to the third power. I'm not going to ask you to do all that in your head. So 4 third is equal to 1 over 64. What I don't want you to do is say 4 to the negative third, because what it's going to do is going to give you that decimal. If you write that down, it's wrong. Okay, I want the fraction. You got to be able to write it as a fraction. 7 to the 0 power. Jeff, what's that going to be?
1.
1. Yep, anything to the 0 power is 1. Anything to the 0 power is 1. Okay, so that's it for those two. Now, here's where you've got to watch is when you have negative numbers and you've got parentheses or you don't have parentheses. If something's in parentheses, that means that whole thing is to the power. So what that means here is that since I got a negative power, I make this 1 over, since this is in parentheses, I put it as negative 5 to the 4th power in the bottom. Now you can use your calculator. What is negative 5 to the 4th power? Okay, so that is absolutely fine. Negative 5. Maddie, let me know what you get. Negative 5 to the 4th power.
Negative 645.
Okay, all right. Now, actually, you got to watch the way this is written. The sign is super important because since it was in parentheses here, when I plug it in the calculator, I absolutely have to put it in parentheses, which will actually make it not negative, but positive. So that should be 1 over 625. That should be 1 over 625.
Why would it change to the positive?
Okay, in general, here's what you got. You got negative 5 times negative 5 times negative 5 times negative 5. That's what negative 5 to the 4th power means, right?
Mm-hmm.
A negative times a negative is always what? Positive. So negative 5 times negative 5 is positive 25. And then negative 5 times negative 5 is positive 25. So you got two positives in the end. Now, what is the overall rule? Here's the overall rule. If this is an even number, if you got a negative number to an even power, it will always be what? No. This one was actually what? Positive. It will always be positive. If you got a negative number to an odd power, if that was a 3 or a 5 or a 7, it's always going to be negative. That's just kind of like the shortcut. Here's why, because of the number of negatives you have. If you have an even number of negatives, then it will always give you, those two will give you a positive, those two will give you a positive. All right.
So you should just turn it into a positive.
For that one, yes. All right, for this second one, D, negative 5 to the negative 4. Is it in parentheses? No, so that means the only thing to the power is the 5. That's what that means. So that 5 is to the power. So now the negative does not move down below. This becomes negative, stays up top with the 1, and it becomes 5 to the 4th power down below. Okay? Because it is not in parentheses, that negative number is not to the power. Well, the negative 1 is not going to get affected. What is 5 to the 4th power? We already figured that to be 625. So this one will be a negative answer. This one will be a positive because of how the parentheses are written. Okay, again, this is a little bit tricky for E and F because you got parentheses in one and you don't have parentheses in the other. Since you have parentheses, that whole thing is to the 0 power. That just equals 1. You would type that into your calculator. Parentheses, negative 5 to the 0 power gives me 1. All right, anybody know what the second last one is? Right.
Negative 1.
It's going to be negative 1 because the negative is not to the power. So the negative is not to power. Only the 5 is. So that gives me that 5 to the 0 power becomes 1. The negative stays in front of it. So you really got to be careful there with how that's written. Okay, what if you have a negative number in the denominator? All right, how about this? And just think about this because you don't have a ton of room to write. What if it's 1 over 2 to the negative third? 1 over 2 to the negative third. So here, really, I'm going to show you a shortcut, but 2 to the negative third is 1 over 2 cubed. And if you do the math, then this becomes 1 divided by 1 over 2 to the third, which becomes 1 times 2 to the third over 1. So long story short, it becomes 2 to the third. So if the negative number is in the denominator, really you can just move it up above and make it positive. So you can make it 2 to the third in the top. So we know 2 to the third is already what? What is 2 to the third? It is Zach, you did it earlier. 8. So if I type in my calculator 1 divided by 2 to the negative third, it will give me 8 back. It's the same as 2 to the third. So think about this. 1 over 3 to the negative second. What do you think that's the same as? What do you think that's the same as? What's that?
One above it.
Well, it's going to be, yeah, but what does that mean? It's going to be 3 squared. You can move it up above and make it the positive exponent. So just pay attention here. So I'm just going to do through a couple real quick. 1 over 5 to the negative fourth power. What do you think that's the same as? Just follow the pattern. Same as positive 5 to the fourth power. Here's your rule. If you have a negative exponent, it's going to move to the other side of the fraction bar based upon whether it's negative or positive. So if I got 1, now what if I throw a letter in there? 1 over x to the negative second, that's the same as x squared.
Why does the negative change?
The negative changes to a positive because of this rule here. We know 2 to the negative third from this rule here. Anything to the negative second, I can write as 1 over. Okay. If it's already in the denominator. Okay, if it's already in the denominator, when I make it 1 over and I do the math, it's going to end up in the numerator. Okay. That's always going to be the case. I know it's a little confusing at first, but that's just try just to do the simple. If it's a negative exponent, to make it positive, move it to the other side. All right, what do you got on your, let's see, an expression that contains negative or zero exponents is not considered to be simplified. Okay, expressions should be rewritten with only positive exponents. So here, from here on out, we can only write it as a positive exponent. So if you look on the bottom there, okay, that cannot be an answer. Why not? Because we got a w to the negative fourth. Any ideas? The 7 and the z are fine. How do I change that w? Any ideas? Just see if you can figure this out. Jeff?
Division.
Tell me what to write.
I don't know.
You don't know? Austin?
Subtract W and Z.
No, we can't do that. It just has to do with the exponent. Ava.
Minus 1 over W4.
Okay. So that w to the negative fourth is 1 over w to the fourth. Since I have more than one thing, here's what I can do. The 7 and the z will stay. That will go down below. That will be my answer. Think of it as a fraction from top and the bottom. If you have a negative exponent, you want to move it to the other side and make it a positive. Everything else has to stay where they're at. The only thing you move are negative exponents. So take a look at part B. All right, we got a couple things going on here. A to the 0. What does anything to the 0 power equal? 1. So that gets replaced with a 1. So that's no longer there. Do I have any negative exponents? Yes. B to the negative second. I need to make it a positive exponent so it goes down below. So b to the negative second goes down below is b squared. Now I look in the bottom. I got c to the negative third. That's a negative exponent. To make it a positive, you move it where? To the top. So that becomes c to the positive third in the top. So once you move it, it changes signs. D to the sixth, it's already positive. Leave it where it's at. So anything positive stays. Anything positive stays. Anything negative needs to move. Okay. All right. All right. Well, C here. Let's take a look at C. Only 4 exponents. Only 4 exponents. X to the negative third. Y to the negative first. All right, that's a negative 2. Is that an exponent? It stays. A to the 6. Is that positive? So it has to stay in the bottom. What's going to be left in the top? Nothing. If there's nothing left in the top, we still got to put something there. What do we put there? 0. A 1. A 1. So there's that. Everything goes, put a 1. So here's what I got. I got negative 2 here. I got a to the 6th. I got x to the 3rd. I got y to the 1st. Now y to the 1st you can just write as a y if you want to. All right, I'm going to give you one to try on your own. Just do it right there beside there, or on the bottom. All right, see what you come up. 3x to the negative 2nd, y cubed over z to the negative 4th. Alex, you got an answer?
No, I just need no over.
That would be answer.
One, two, three.
All right. All right, we're going. All right, the big thing here. Watch the 3. 3. Does it have an exponent on it?
No.
Don't move it. Don't move it. Leave the 3. Only thing that moves is things with an exponent. So that stays. X to the negative 2nd. That's a negative exponent. It has to go down below as x squared. Y cubed. Positive 3. Stays where it's at. What about z to the negative 4th? Mason? Move it to the top. Okay. Z to the positive 4. Okay, so that's what we got. Ellie?
Does it matter like what order the y and the z are in? Because I did 3z to the 4th power and then y to the 3rd power. Does it matter like which order it goes in?
I would accept that as the same because they're being multiplied. Now, here's the deal. Normally, what they're going to do is they're going to put them in alphabetical order. So if you see an answer with y cubed z to the 4th, like I said, it's going to be the same, and that's normally how it's going to be written.
Yeah, I don't know how to do it.
Okay, for that one. All right, we're going to keep. This is something that takes a little bit of time, and we're going to keep hitting that. We're going to keep hitting that. All right, flip it over on the back. Now, from here on out, if you get an answer, you cannot have a negative exponent. You cannot have a 0 exponent. Okay, that's part of our rules. Now, what happens when we multiply? There's a little bit of a trick. We want to keep this as a power. 2 to the 4th. I want you to think about that. That means how many 2's? 2 to the 4th. Reese, how many 2's is that?
4.
4 of them. 2 to the 4th, and just pay attention here. Jenna, 2 to the 5th means how many 2's?
5.
5 2's. How many 2's do I have total then that I'm multiplying together, Jeff?
5.
You're not paying attention. 8. 9. I got 4 2's here. I got 5 2's here. I got 9 2's. So what do you think the shortcut is if I got 2 to the 4th times 2 to the 5th? I want to make it 2 to a power. What do you think you do to those powers? How do I get 9? Zach? How do I get that with the 4 and the 5? Addie?
Just add them together.
Add them together. 2 to the 9. Maybe I wasn't clear. So that's it. 2 to the 9. So what that means, this is our product of powers property. If you got a base to a power times a base to a power, you are going to make that a to the m plus n power. So you're going to add those. So write that down there. A to the m plus n. So what do you think x squared times x cubed is going to be? It's going to be x to the what power? Right? X to the 5th power. That's going to be x to the 5th. Doesn't matter whether we have a variable or a number, it's going to be x to the 5th. So if I had 2 squared times 2 cubed, that would be 2 to the 5th power. Okay, so we're going to add those together. 3 squared times 3 to the 5th is 3 to the what? 7. Add them together. 2 plus 5. 7. So that's what we do. 3 to the 7. Okay. Only with like bases, which means they have to have the same base. This r is not the same as a q. So what are the only two exponents we're going to add together?
The 2 cubed, like the 3 and 6.
The 3 and the 6. So I'm going to write that 3 plus 6 is q to the 9th, and then I just got to keep that as r squared. You can't do anything else with it. You just leave that. So that would simplify to q to the 9th r squared. And what's that third one look like? Okay. If you don't, like an n, there's not a power listed, right? There's really a power there. Anybody know what it is? A 1. Automatically a 1. Automatically a 1. I got 3 things. It doesn't matter whether I got 2 or 3 or 4. What are you going to do to the exponents? We're going to add them. So what's 3 plus -4 plus 1? What does that add up to? 0. So this becomes n to the 0. You're not allowed to leave that as an answer because n to the 0 equals 1. So what's my answer? 1. N to the 0 is 1. So that whole thing would become a 1. Why didn't the other ones become a 1? Because they did not have a 0 exponent. So our rules still apply from the previous one. Okay, so we got a 1. All right, again, pay attention. Just going to develop this rule. We don't know it yet. If we divide, so think about this. 3 to the 5th means how many? Maddie, how many 3s would that be? 5. So I got 3 times 3 times 3 times 3 times 3. 3 cubed. All right, how many 3s is that? Okay, Alex. 3 cubed, how many 3s is that? 3 of them. So it's 3 times 3 times 3. All right, think about canceling. Anything on the top is the same on the bottom, cancel. So when I am done, how many 3s do I have? 2. What do you think the shortcut is? If I got 3 to the 5th over 3 cubed, what can I do to get 3 squared? What can I do with these exponents? Subtract them. That's our rule. So here's our rule. A to the m over a to the n becomes a to the m minus n. Subtract them. Okay, what did we do when we multiplied? We added them, which was right above. For this one here, we subtract. X to the 7th divided by x squared means you have 7 x's on top, 2 on bottom, but in the end, we're going to have x to the 7 minus 2 is 5. X to the 5th. So I got x to the 5th. Okay, when you have a, oops. All right, 2 to the 7th over 2 squared becomes 2 to the what? 2 to the 5th. 7 minus 2 is 5. 2 to the 5th. Good. X to the 4th over x cubed. All right. X to the what power? First, but you only need to write the first power. If it's x to the first power, you can just write it as x. Already understood to be that. Okay? So that is x. And what do you think about this? Ooh, holy cow. This is a rough one. This is a rough one. Any ideas here?
I don't know, but like you do 3 to the negative first.
Okay, 1 minus 2 is -1. Agree with that.
And then 3 minus 4, which would get you -1.
4 to the negative first. Agree with that.
And then 5 minus 3 is 2.
So 5 squared. Agree with that. Now, why would I mark, you left that as an answer. Why would it get marked wrong? There's negative exponents. We go back to what we did on the front. How do I get rid of a negative exponent? You move it to the other side of the fraction bar. Okay, so any ideas how I would write that final answer? Okay, Zach?
5 to the power 3.
Now power of 3, what's 5 to the power of?
2.
Okay, 5 to the power of 2.
And then over 3 to the 1 and 1.
Good. Now, you don't really need to write the power of 1 at this point. If you did, I would not mark it wrong. But I just want to make you understand that those would be the same. Now, depending on how they want you to write it, at the end, 5 squared would be 25, and 3 times 4 would be 12. So those would be equivalent. Right now, go ahead and keep it in the power form. So 5 squared over 3 times 4.
How come for B it's just X?
What do we do to the powers when it's a division problem? What do we do to those? Subtract it. What's 4 minus 3?
1.
1. X to the first is the same as X. Okay, Y to the first is the same as Y. If you wrote to the first power, I would accept it for now, but you just got to know it's eventually it's the same. Okay. All right, good. All right, stick with me. We're almost done. I know there's a lot going on here today. All right, again, pay attention to this. All right, think about this. Anything squared means you multiply it how many times together? 2 times. So this would be 4 cubed times 4 cubed. Go back to the top of that page. What do I do when I multiply two things that have the same base? What do I do to their exponents? Add them. What's 3 plus 3? 6. So this is 4 to the 6. So how do I go from 4 cubed? What's the shortcut? Oh, why is it? Hold on. I'm going to do it over here. 4 cubed to the second power is 4 to the 6. What can I do to those two numbers to get 6? Right.
Multiply the exponent that's in the parentheses and the one that's on the outside.
Multiply the 3 and the 2 together. Let's see if this will at least let me do it. All right, I'm going to, hold on, save as, desktop, save, yes. Okay, let me see what you get next. All right, so where you have a to the m times n, what do you think you're going to put there? A to the m times n. You're going to put a to the, how do you show multiplication? Put them right next to each other. A to the m n. So put that, yep, a to the m times n. All right, what's the next one say to the right of it there? Gavin, what's it say to the right of it?
In parentheses, it's x to the 4th power, and then a 3.
Then a 3 on the outside?
Yeah.
So what do you think that's going to be, Gavin? X to what power? What do you think you do to those two numbers? Multiply them. 4 times 3 is? 12. Here's what's going on. Anything to the third power, you would write down 3 times. X to the 4th times x to the 4th times x to the 4th. Then you would add those together to get 12. But we can do the shortcut. I can just multiply 4 times 3 and get 12. All right, so that would be that case there. What's the next one below that, Ava? Hold on. Yeah, A. 5, is it 5 squared to the 4th? Is that what it looks like? Okay. So A would be 5 squared to the 4th power. What's that going to equal? It's going to equal 5 to the, Ava? 8th power. Good. 5 to the 8th power. Let's see if this came back or not. All right, there we go. Let's see if it actually works. So 5 to the 8th power. All right, B. 4 cubed to the 0 power. What do I do to the 3 and the 0? Multiply them. What's 0 times 3? 0. What's 4 to the 0 power? 1. Yes, very good. 1. Oh, all right. This is combining a couple rules. So, hi, Carla. 3 times negative 5 is what? 3 times negative 5 is negative 15. times x to the fourth. You can't have two x's. What can I do to those powers? This is the rule from the top. What do I do when I multiply? Adam, what's negative 15 plus 4? Negative 11. But you can't leave that as your answer, because you can't have a negative exponent. So, Damien, how do you think I write it?
1 over x.
Yes. Final answer, 1 over x to the 11. Very good. Very good. All right, last one. All right, we got two things going on here. This is called a power to a power. The numbers are right next to each other. Multiply them together. A to the 12. A to the negative second times negative third. Negative 2 times negative 3 is? Not negative 6. 6. A to the 12 times A to the 6. It's going to be A to the what? A to the 18th, because we're going to add them. So we got that other rule there that we got to put on here. I'm looking for the guided notes for you. There you go. Okay. Homework. These don't take long. All right. Page 304, 1 through 27, odd. You have to write the original problem down. It's not like equations where there's a bunch of work to do. It's just recognizing what to do. No zero exponents, no negative exponents. Carly, did you turn in your quiz last week? Okay. All right, that's the practice quiz. All right, I'll just keep this so I can mark down your homework.
You're using my
All right, guys, have a good day. What about like 10 years from now?
Have a nice day.
See you, Griffin.